The secrets of our ancestors are not lost. The secret of this ancient engineering will amaze you.
A heavy iron sledgehammer swings with bone-crushing force against a solid black stone door. The door doesn't budge. Instead, the hammer shatters. This is the result of Achaemenid engineering. To see how they buried the ancient world's gold, subscribe and hit the like button. Most accounts of ancient wealth focus on the treasure chests found in grand stone palaces, eventually seized by conquerors like Alexander the Great. But the gold discovered in the central halls of Susa and Persepolis was merely the floating capital, currency used for the daily affairs of state. The Imperial Emergency Strategic Reserves were moved far away from the city centers. Large caravans hauled the empire's primary fortune toward desolate, vertical mountain ridges. Within 48 hours, the sovereign wealth vanished into the solid rock. The Hazarapot, the king's chief engineer, was tasked with building subterranean vaults that could withstand human invaders, flash floods, and massive earthquakes using the materials available in 480 BC. These vaults functioned as high-tech, self-defending machines, using geometric calculations and fluid dynamics to secure the hoard against both nature and man. Typical ancient security relied on mortar, iron chains, or bronze padlocks. These materials are rigid, meaning a crew of grave robbers with heavy iron mallets can eventually crap them through repetitive impact. The Achaemenid solution moved away from mechanical locks. They carved multi-ton limestone doors with opposing dovetail-shaped tracks. An iron core bar was dropped into the channels. Metallurgists then poured a superheated lead antimony alloy into the cavity. Expanding as it cools, this alloy fills every microscopic pore, creating an unbreakable chemical-mechanical seal. When a sledgehammer hit this seal, the lead-antimony mixture acted as an impact damper. It absorbed the kinetic energy and deformed into the stone grooves, which only served to lock the door tighter with every blow. Bypassing this lock required melting the mountain wall with industrial furnaces, a feat that was impossible in the dark, oxygen-depleted tunnels of the vault system. The Iranian Plateau is a highly seismic zone, where 7.5 magnitude earthquakes can snap standard cemented walls through shear stress. To counter this, the Achaemenid engineers built subterranean walls without using any mortar or cement. They carved massive blocks into multi-faceted polygons, interlocking at irregular angles. During an earthquake, mortarless joints allowed the stones to glide and vibrate. The wall behaved like fluid, absorbing the kinetic energy. Afterward, gravity forced the self-centering blocks to slide down into perfect alignment. By utilizing the Earth's own gravity and kinetic force, the architects ensured the vault would automatically reset its own structural integrity after a major strike. The most persistent threat was underground humidity and acidic groundwater, which can reduce silver, silk, and leather to oxidized sludge over several decades. Engineers built a 3-tier thermal matrix. First, an outer jacket of coarse gravel funnels rainwater away. Next, a waterproof layer of alkaline blue clay blocks seeping moisture. Finally, a blanket of pulverized charcoal absorbs internal humidity, entirely preventing mold and fungi. Because of this hydrophobic grid, silk garments and leather pouches stored in these chambers have been found in the same condition as the day they were first lowered into the earth. The Persian royal architects integrated chemistry, soil physics, and gravity into the very structure of the earth to neutralize specific threats to the imperial treasury. The structural integrity of these sites reflects the specific geometric calculations used by the Hazarapot to secure the royal hoards. But these defensive systems were only the beginning. What happened when a determined intruder managed to breach these outer seals? In Part 2, we're moving from defensive engineering to active lethality. We will break down the acoustic early warning grids and the self-flooding subterranean aquifer vaults. And we will look at the gravity-driven sand siphon guillotines designed to bury intruders under 50 tons of mountain rock in total silence. We'll see you in Part 2.
The Antimony-Lead Fusion Locks and earthquake-proof foundations we explored in Part 1 were designed for endurance. But even the most sophisticated passive defenses face a critical limitation: they eventually yield to the persistence of time. A serious threat to the empire's wealth wasn't just decay, but a focused, long-term siege. An organized invading army or a ring of internal conspirators could locate a vault and use heavy engineering tools to spend weeks or months battering the stone platform. To counter a high-intensity siege, the Hazarapet, the king's chief architect, shifted from static defenses to a living, reactive subterranean environment. He engineered systems that utilized the mountain's own physical properties to detect and eliminate intruders. This strategy integrated security into the geology itself. The Hazarapet transformed the mountain from a shell into a combatant, using the environment to actively repel an attack. This active defense began at the perimeter. Imagine an intruder striking a pickaxe into the mountain's outer face, unaware that the impact just sent a signal directly to a regional garrison. This was achieved by anchoring the vault's foundation directly into natural quartz veins, known as Rajayasang. Quartz is an extremely high-density crystal. It acts as a natural conduit, transmitting kinetic vibrations over miles with almost no loss in frequency. The quartz vein carried these vibrations deep into the mountain, terminating in a specialized amplification room. This chamber was built directly beneath an imperial military outpost, often located miles away from the vault's actual entrance. Inside the room, the architects embedded dozens of kamre eguli, hollow stone jars made of hard ring-fired clay. Each jar was mathematically calibrated to a specific frequency. When the vibration from a distant pickaxe hit these jars, they acted as resonators, multiplying the sound waves. In the guard room above, the faint metallic scrape of a chisel a mile away echoed like a loud hammer strike. The garrison could identify an attack instantly, allowing them to ride out and intercept looters long before they reached the inner seals. By mapping the mountain's anatomy, the architects turned the entire valley into an acoustic sensor. It removed the intruder's primary advantage, the ability to work in secret. If an intruder managed to bypass the acoustic grid and breach the entrance, they encountered a secondary hydraulic trap. The simple act of stepping on a specific, balanced stone in the staircase, the trigger step, initiated a total environmental failure. These vaults were often built adjacent to high-pressure artesian aquifers or underground rivers. A thick dam wall of waterproof sarouge concrete held the water back, keeping the gold vault dry and accessible to the king's officials. When the trigger step was depressed, it acted as a lever that shifted a heavy internal counterweight. This weight dislodged the primary support pillar of the sarouge dam, causing the barrier to lose its structural integrity. Millions of gallons of high-pressure water instantly flood the corridors. In under 90 seconds, the entire complex fills from floor to ceiling, drowning any intruders. The water didn't drain away. The vault became a permanent extension of the natural aquifer. While the gold chests remained protected in their own waterproof sarouge jackets, the vault itself became an underwater cave, inaccessible to anyone without heavy imperial pumping machinery. This system moved beyond simple obstruction. It permanently changed the physical state of the room, using the pressure of the Earth's own water to deny access. For the innermost sanctum, where the crown jewels were stored, the architects employed a system based on fluid friction. A looter might reach the final room and attempt to pull a decoy block from the wall, triggering the final failsafe. Suspended above them was a 50-ton granite slab. This gargantuan ceiling wasn't supported by the walls, but by a series of hidden vertical pillars. The base of each pillar sat inside a deep shaft filled with ultra-fine dry river sand. As long as the sand was trapped, its density and friction held the pillars stable, keeping the 50-ton ceiling in place. Removing the decoy block opened a hidden drain hole at the bottom of these shafts. The sand would siphon out silently. Without the friction of the sand to support them, the stone pillars began to sink into the emptying cavities. Within minutes, the granite ceiling would slide down its tracks, acting as a massive guillotine. It would crush anything in the room and seal the entrance with a wall of granite that no chisel could easily penetrate. In the deepest part of the mountain, the Hazarapet relied on gravity and friction, laws of physics that remain constant regardless of time or technology. Looking at the remains of the Achaemenid treasuries, we see more than just ruins. We see the final layer of a sophisticated mechanical defense grid operating without human intervention. These architects converted the resonance of quartz, the pressure of aquifers,
and the friction of sand into an automated security force. They didn't just build walls, they calculated precise physical interactions to protect the empire's core. While conquerors like Alexander could burn palaces of wood, these mathematically governed systems remained outside the reach of conventional warfare. The mountain itself became an obstacle that brute force alone could not solve. These systems provided a level of protection for the king's most sacred artifacts that relied on the absolute precision of physics rather than the reliability of guards. Ultimately, the Achaemenid treasuries demonstrate that the most effective defenses were not found in the thickness of the stone, but rather in the sheer intellectual labor required to turn the natural laws of the universe into an eternal, unyielding guardian.